Okay, think about this for a second. What if your programming language could do more than just build applications? What if it could actually reason about them? Well, today we're diving into Bayan, a brand new language that's designed to do exactly that by smashing two totally different worlds of code together.
For as long as I can remember, programming has been kind of divided. We use one set of tools to actually build things, that's the how, and then a completely different set of tools for logical reasoning, that's the what. And these two worlds, they almost never cross paths.
So, on one side, you have your workhorses, right? Languages like Python or JavaScript. They're fantastic for giving the computer step by step commands. Then, way over on the other side, you have these logic languages, like Prolog, which are amazing at working with facts and rules to figure things out. But traditionally, you always had to pick a side.
Well, that's where Bayan comes in. It steps onto the scene with this really simple but honestly super powerful idea. What if you didn't have to choose? What if you could build and reason in the exact same file with the exact same language? And let's be clear, this isn't just some minor update to a language we already know. Bayan has been designed from the ground up around a fundamentally new way of thinking. And the creators of Bayan are not exactly shy about it. I mean, this claim is pulled right from their own documentation. They see their creation as the very first language to truly and seamlessly merge these different ways of coding. So, how in the world do they pull it off? Well, the secret sauce here is that it fuses three major programming paradigms into a single unified syntax. You're not switching modes, you're not importing special libraries, you just write the code. It all just works together.
Okay, so let's break down the three pillars that Bayan is built on. Now, the first two are probably going to sound pretty familiar to you, but it's that third one, and especially how they all play together, that is the real game changer.
First up, imperative programming. This is the classic stuff, the bread and butter. You're basically giving the computer a to-do list. Do this, then do that. It's really the foundation of most languages we use every single day. Second, we've got object-oriented programming, or OOP. This is all about organizing your code into these reusable blueprints we call classes, which then create objects. It's how pretty much all modern, complex applications are structured and kept manageable. And now for the third piece of the puzzle. And this is where it gets really interesting, logic programming. So instead of telling the computer how to do something, you just give it a set of facts and rules. And then you just ask it questions, and its built-in inference engine goes and finds the answers for you. This is that reasoning part we've been talking about.
Okay, but before we get into how all these paradigms actually merge together, there's another feature that makes Bayan just completely unique. It's fully bilingual, designed from its very core to be written in either English or Arabic.
And we're not just talking about being able to type Arabic text in your code. No, the actual keywords of the language, the commands themselves, have a direct one-to-one Arabic equivalent. The keyword if is also ida, and class is sunf. You can write code that is 100% functionally identical in either language. You can even mix and match them, which is wild. So check this out. Here's a simple class that defines a car, and it's written entirely with Arabic keywords. And this isn't just a picture. This is real, functioning Bayan code. That is a huge, powerful statement about making programming more accessible to people all over the world.
All right, so we've got these three paradigms, we've got two languages. Let's get to the main event. How does Bayesian actually smash these two worlds of building and reasoning together, especially when you're talking about something like AI? So imagine for a moment you're building a medical expert system. You'd probably start with a standard object-oriented class, something like this. You have a diagnose method, and it takes in the patient's symptoms. Now, in a normal language, you'd be stuck writing this giant, messy chain of if this, then that statements. But what if you could just ask a logic engine for the diagnosis?
And here it is. This is the breakthrough. Look at what Bayan lets you do, right inside a regular method of a class. That line that starts with the dash nothing, that's not a comment, it's not a string, it is live executable logic code. It's literally asking the engine, based on all the facts and rules I know, can you find a disease that matches these patients' symptoms? The engine finds it, puts the answer into that dash disease variable, and then you just return it. It's incredible. So you can see why this is such a huge deal for anyone working in AI. You can build these complex expert systems where the rules are kept totally separate from the application code. You can even build objects that have their own little knowledge bases inside them. It just simplifies the whole architecture of these incredibly complex AI systems. But wait, there's more. Seriously. Bayan takes this whole reasoning thing one massive step further. It has a built-in engine that isn't just designed to answer what, but to actually understand why. And it pulls this off with something called a causal network engine. Now, causal reasoning is this whole field in AI that's not about just finding patterns or correlations. It's about trying to model and understand true cause and effect. And the way Bayan lets you build these causal maps is just super intuitive. You basically define your concepts as nodes, then you connect them using special causal relationship types, and then you can just ask the network questions to figure out the chain of cause and effect. And this is the really cool part. The language gives you this incredibly rich vocabulary to describe these connections. It's not just A causes B. You get 12 different types. So you can say something directly causes something else, or that it just enables it, or that it prevents it from happening. You can even say it enhances or weakens it. This lets you build these incredibly detailed and realistic models of the world right in your code. Which really brings us to the big final question here. Bayan is more than just a new syntax. It's a whole new way of thinking about what our code can even do. It's proposing a future where our programs don't just follow instructions, but can actually represent knowledge, reason logically, and even understand causality. So I'll leave you with this. If the code you write could truly understand why things happen, what kind of problems would you be able to solve?